Hello everyone. In this mathematics, calculus and trigonometry tutorial, we provide clear and concise explanation of the law of sines. The law of sines is a very important trigonometric law that is often used in mechanical and electrical engineering, as well as in robotics and physics. Furthermore, we will solve several examples that illustrate the application of the law of sines. Let's start with the basic definitions. An acute angle is an angle that is larger than 0 degrees and less than 90 degrees. Then, an obtuse angle is an angle that is larger than 90 degrees and that is less than 180 degrees. A triangle is called right or the right triangle if two sides are perpendicular. That is, a right triangle has two sides that are creating an angle of 90 degrees. An angle of 90 degrees is called a right angle. A triangle is called oblique or oblique triangle if none of its angles is a right angle. This figure over here shows two examples of oblique triangles. Over here we can see an oblique triangle with one obtuse angle and with two acute angles. On the other hand, over here we can see an oblique triangle with all three acute angles. Next, let's clarify what does it mean to solve a triangle. To solve a triangle means to determine the numerical values of its sides and angles. For the time being, let's focus on this right triangle. To solve this right triangle, we need to know either one of the acute angles, for example, alpha or beta, and one of the sides. Or we need to know two sides, for example, this side and this side. In this case, we can use the Pythagorean theorem to calculate the third side and basic trigonometry to compute other angles. Let's focus on the first case. The goal is to solve the right triangle if an acute angle and one of the sides are known. For example, let us assume that the angle alpha is known and the side C is also known. Our task is to compute the sides A and B as well as the angle beta. From this right triangle, it follows that B, that is this side, is simply C multiplying cosine of alpha. Similarly, A is C multiplying the sine of alpha. In this way, by knowing C and alpha, we can compute A and B. Then, we can use this very well-known formula to compute the other angle beta. Namely, the sum of the angles in a triangle is equal to 180 degrees. The angles are alpha, beta, and 90. Here they are. From this equation, it follows that beta is actually 90 minus alpha. And in this way, we can solve the right triangle. Next, let's focus on the second case. Our goal is to solve the right triangle if two sides are known. Without the loss of generality, let us assume that the sides A and B are known. Then, by using the Pythagorean theorem, we have C squared is equal to A squared plus B squared. From this equation, it follows that C is the square root of A squared plus B squared. In this way, we can compute C. On the other hand, the angle alpha can be determined by observing that tan alpha is A over B. From this equation, it follows that alpha is arctan or the inverse tan function of A over B. And that's it. The angle beta is of course determined by very well-known formula. That is, the beta will be simply 90 minus alpha. The next natural question is how to solve oblique triangles. Depending on the case and what is given, we either need to use the law of sines or the law of cosines. The law of sines is covered in this lecture and the law of cosines will be covered in the next lecture. From a mathematical point of view, the law of sines can be expressed by this equation. To understand this equation, let us closely examine this oblique triangle. The lengths of the sides of this triangle are A, B, and C, and the acute angles are alpha, beta, and gamma. We have that A over sine alpha, A over sine alpha is equal to B over sine beta, B over sine beta is equal to C over sine gamma, C over sine gamma. Here's how I memorize this formula. In the numerator, I have the side, and in the denominator, I have a sine of the opposite angle. For example, if I look at this side, its opposite angle is beta. Then I know that in the numerator, I will have B, and in the denominator, I will have sine beta. We use the law of sines to solve oblique triangles when two angles and the side are known. For example, if this angle and this angle and this side are known. Then, we can also use the law of sines to solve a triangle when two sides are known and one angle that is not enclosed by these sides is known. Let's see what's written over here. Two sides are known and one angle that is not enclosed by these sides is known. For example, we can assume that C is known and B is known and beta is known. If that's the case, then we can use the law of sines. Here, it's very important to keep in mind the following. In this case, under certain scenarios, it might happen that the triangle is not uniquely determined and there might be two solutions for the corresponding angle. If this happens, this case is called the ambiguous case. If that's the case, then we need to use some physical a priori information to actually determine the angles. For example, we know that all the angles are acute, or some angle is, for example, obtuse. Next, let's solve the first example illustrating the application of the law of sines. This example explains how to solve a triangle when two angles and a side are given. Let us assume that in this triangle, the angle alpha is equal to 60 degrees, the angle gamma is equal to 40 degrees, and this side C is equal to 4. Our goal is to solve this triangle. That is, we need to determine the side B and the side A. That is, we need to determine the lengths of these sides as well as this angle beta. Okay, first of all, let's determine the angle beta. We know that the sum of the angles in a triangle is equal to 180 degrees. Consequently, we can write alpha plus beta plus gamma is equal to 180. Alpha is 60, beta is not known, and gamma is 40. And this should be equal to 180 degrees. From here, we obtain that beta is 180 minus 60 minus 40. That is, beta is equal to 80 degrees. The next step when solving these problems is to write the general form of the law of sines. Let's write the general form. In the general form, we have A over sine alpha is equal to B over sine beta is equal to C over sine gamma. The next step is to substitute the given values. Let's see. Over here we can see that C is given, gamma is given, and the angle alpha is given. So let's substitute the values. We have A over sine alpha is 60 is equal to B over beta is also given over here since we calculated. So we can express it as sine 80, and this is equal to c, and c is given 4, over gamma is equal to 40. Consequently, we write sine 40. From these equations, we can express a and b. Let's do that. By combining this part over here and this part over here, we can actually compute a. A is equal to 4 multiplying sine 60 over sine 40. Then, by combining this part over here and this part over here, we can obtain b. b is equal to 4 multiplying sine 80 over sine 40. Here's the Python code for solving this problem. Here I specify c, I specify alpha in degrees, and then I convert it to radians. Then I specify beta in degrees and I convert it to radians, and I specify gamma in degrees and I convert it to radians. And over here I implemented these two equations. Here's how they look. Let's evaluate this and let's see the result. A is equal to this number and b is equal to this number. And I will write a rounded version of these two numbers over here. A is equal to 6.128. Actually, this is the expression for b. I apologize. So b should be 6.128 and a should be 5.389. And that's it. Next, let's solve the second example. This example explains how to solve a triangle when two sides and an angle are given. In this case, we assume that the angle gamma is given and it's equal to 40 degrees, and we assume that two sides are given. This side is equal to 2 and this side is equal to 3. The first step is to write the general form of the law of sines. Let's do that. We have a over sine alpha is equal to b over sine beta is equal to c over sine gamma. The next step is to substitute the given values. Let's see what's given over here. We can see that b, c, and the angle gamma are given. Consequently, let's substitute the corresponding values. We have a over sine alpha, and nothing is given over here. Then over here, b is given. We have 2 over sine beta. And over here, we can see that c is given. This is equal to 3. And gamma is given. We have sine of 40. Okay, let's see. Over here, both a and alpha are unknown. However, over here we can see that 2 is known, however beta is not known, and over here we can see that 3 over sine 40 are actually known. Consequently, we can compute this fraction. From this part over here and this part over here, we can actually express sine beta. Let's do that. It follows that sine beta is actually equal to, let's see, 2 over 3 multiplying sine 40. Let's double check this. We can see that beta goes here, sine 40 goes here, and 3 goes down. And that's exactly what's written over here. From this equation, it follows that beta is actually inverse sine or arc sine of the right hand side, and the right hand side is 2 over 3 multiplying sine 40. If you substitute this in Python or in your calculator, you will obtain that beta in radians is actually 0.44285 radians. If you convert these radians into degrees, you will see that beta is approximately equal to 25.374 degrees. Since we have determined beta and we know this angle, we can simply determine alpha. Namely, we know that the sum of the angles in a triangle is equal to 180 degrees. So we can write alpha plus beta plus gamma is equal to 180. From this equation, it follows that alpha is actually 180 minus beta minus gamma, and if you substitute the values, you will get that alpha is approximately 114.626 degrees. Let me double check this. 114.626. That's correct. Since we have determined alpha, from this part over here and this part over here, we can actually compute A. We have that A is equal to 3 multiplying sine alpha over sine 40. This is equal to 3 multiplying sine of 114.626 over sine 40. And if you substitute this in your calculator or in Python, you will obtain that A is equal to 4.2427, and that's it. Over here is my Python code for solving this problem. First of all, I import NumPy, then over here I define B, C, and the angle gamma in radians. Angle gamma in degrees is 40, and if I multiply 40 by 2 pi over 360, I will obtain radians. Then over here I compute beta by using the derived formula. Then over here I convert beta from radians to degrees, since the function numpy.arcsine will actually return the radians. However, I need degrees. Over here I compute alpha, then alpha is computed in degrees. I convert alpha back to radians, and over here I compute A, and that's it. And as the result, you will obtain beta in degrees, alpha in degrees, and you will obtain A. And that's it.